Hi to everyone. I am Dr. VNSR Venkateswara Rao, working as an Associate Professor in the Department of Chemistry in Institute of Aeronautical Engineering. So, today I would like to give the topic on the introduction to the analytical chemistry. Okay, so first of all, we see what are the topics covered in today's section. So, first of all, the topics which are covered in today's section, analytical chemistry, introduction to analytical chemistry. So, mainly the first one is the what are the methods used in analytical chemistry. After that, we see what are the branches of the analytical chemistry. Next, we see what are the importance of analytical chemistry and finish the topic with the applications of analytical chemistry. So, mainly the lecture based on the 4 points. One is the methods of analytical chemistry. Second one, branches. What are the different types of the branches in analytical chemistry. After that, we see what is the importance of the analytical chemistry and applications of the analytical chemistry. Okay, let us start the introduction. So, first of all, what is analytical chemistry? So, from the title, we understood that the chemistry which involves the analysis. Mainly, it involves the both qualitative and quantitative analysis. Okay, so first of all, what is analytical chemistry? Analytical chemistry is the branch of chemistry that deals with the analysis of different substances. So, substances means which are the especially chemical compounds that may be either inorganic compounds or organic compounds which involve the analysis of the chemistry. Okay, so the analysis which related to the either organic or inorganic substances are called as the analysis of the chemistry. Such analysis is involved in the analytical chemistry. Now, analytical chemistry involves the separation, identification, and the quantification of the matter. Matter means substance. So, separation means the technique which is mainly involved in the mixture of the components into individual components, especially complex compounds. Complex compounds and mixture of the substances. Okay, so these are mainly involved in the separation of mixture of components into individual components. Next one, identification. Identification of the compounds. So, identification of the compounds means what are the components present in a given sample. So, that is called identification of the compound. After that, quantification of the matter. So, quantification of the matter means which mainly involves the to determine the quantity of a given compound present in a sample substance. Okay. After that, it involves the use of classical methods along with the modern methods involving the use of the scientific instruments. So, scientific instruments means mainly it involves the principle which is mainly based on the classical methods of analysis. So, like scientific instruments means pH meter. Next one, conductivity meter. After that, we see potentiometer. So, for example, if you consider the pH meter, so which is mainly applicable to determine the pH of a given sample compound. So, further, this pH is mainly divided into different types of the categories. The overall pH range is the 0 to 14. So, out of 0 to 14, it involves the three types of the mediums. One is acidic medium, and second one is the neutral medium, and third one is the basic medium. Okay, so in case of the acidic medium, it involves the 0 to 6.5 pH medium, whereas 0 to up to 6.9 also, and 7 means exactly neutral medium. Next, 7.1 to 14 is a basic medium. So, by using this pH meter, we identify the what is the pH of a given sample compound. Based on the pH value, we can set the medium of a substance. That may be acidic substances or neutral substances or basic substances. But in olden days, we use the litmus paper, like red litmus paper and blue litmus paper. So, acidic medium red litmus changes to blue, whereas basic medium blue litmus changes to red. Okay, so based on this classical methods of analysis, this pH meter is takes place. After that, we see conductivity meter. Conductivity meter means which is mainly used to determine the end point of a reaction based on the conductivity physical parameter. Okay, and it is mainly applicable to, especially in the case of the neutralization titrations, especially in the case of the mixture of the components. And third one is the potentiometer. So potentiometer means it involves the endpoint of a reaction based on a potential. So potential is nothing but it is mainly observed by the whenever the charge transfer takes place. So it is mainly applicable in the case of the redox titrations. The previous conductivity meter is based on the conductivity. So conductivity is nothing but a mobility of ions. So totally there are three types of the analytical instruments. One is pH meter, and second one is the conductivity meter, and third one is the potentiometer. Okay, so pH meter is mainly based on the value of the pH of a given sample substance, and also conductivity meter, second one, is mainly depends upon the to determine the conductivity of a given substance. Based on that conductivity parameter, we can find out the endpoint of a like neutralization reactions. And third one is the potentiometer, which is mainly based on the parameter potentials, and it especially used for the redox titrations. After that, analytical chemistry involves the following methods. Now we see the process of separation of isolates, the required chemical species which is to be analyzed from a mixer. So that means already we said that what is the separation? Separation is nothing but a mixture of the components into individual components. So especially in the case of the synthesis and isolation of a component. Isolation is nothing but a purification of a substance. So purification is nothing but a to identify and separate out that individual component from the mixture of the components. After that, the second test is the identification of the analyte substances is achieved via the method of the qualitative analysis. So identification is nothing but to find out the required substance from a given sample compound. Especially it is applicable to the systematic procedure for qualitative analysis. Systematic procedure for qualitative analysis. Okay, so this analysis mainly based on the salt analysis. Salt analysis means which involves the both cations and anions. So initially we identify the what is the anion given sample compound. After that we finalize the cation. Finally we repeat the mixture based on the salt. So that's why this is called as salt analysis. So after that we see the concentration of the analyte in a given mixture can be determined with the help of the quantitative analysis. So quantitative analysis, that means the analysis which is mainly involved to determine the amount of a substance present in a given sample compound. To determine amount of a substance present in a given sample compound. So this quantitative analysis mainly based on the both the volumetric analysis and gravimetric analysis. So one is quantitative analysis is further classified into quantitative analysis is further classified into two types. One is volumetric analysis and second one gravimetric analysis. So what is the difference between the volumetric and gravimetric analysis? So volumetric analysis is nothing but the analysis which is mainly depends upon the difference in volumes, whereas gravimetric analysis mainly depends in the difference in mass of the substance. So that is the difference between the volumetric analysis and gravimetric analysis. These two analyses are combined to called as a quantitative analysis. Okay, gravimetric analysis and volumetric analysis. Next, today the field of the analytical chemistry generally involves the use of modern and sophisticated instruments. So sophisticated means the instruments are present in the very advanced and stylish mode, whereas modern instruments nothing but a recent instruments. However, the principles upon which these instruments are built can be traced to more traditional techniques. So that means each and everything. So previously I said that there are different types of the instruments: pH meter, conductivity meter. After that we see potentiometer. So for example, if you consider the conductivity meter, so conductivity meter, which is mainly applicable to determine the end point of a neutralization reaction. So neutralization reactions means which is mainly depends upon the initially traditional methods by using the like methyl orange, phenolphthalein, methyl red indicators to determine the end point of reaction. But by using the, in case of the conductometry, there is no need of the indicator, and also the titration done by very low concentrations. So that are the importance of the instrumental titrations compared to a classical methods of analysis. After that we see gravimetric analysis. Already I said that the definition for a gravimetric analysis is nothing but it is based on the difference in mass of a substances. So this is a classical method of quantitative analysis which can be used in the analytical chemistry to determine the amount of water in hydrate by heating it and calculating the weight of the water lost. So for example, if you consider a analysis of coal, so in case of analysis of coal, there are two types of the analysis. One is proximate analysis and another one is the ultimate analysis. Proximate, second one is ultimate analysis. One is proximate analysis, second one is ultimate analysis. Especially in the case of the proximate analysis, there is one type of important content, that is determination of the moisture. So determination of the moisture means initially we consider 1 gram of the coal sample is heated in a oven nearly 100 to 115 degrees centigrade. After some time gap, what happens? The moisture content present in the coal will be evaporated. So now we calculate the what is the percentage of moisture present in a given coal fuel compound. So that is the formula. Percentage of the moisture is equal to loss in weight of coal by initial weight of coal into 100. Okay, so the similar test will also comes under category of the gravimetric analysis. So that's why you said that the gravimetric analysis is one of the classical methods of analysis, and it is also mainly includes to determine the amount of water present in a hydrate by heating it and calculating the amount of weight of the water lost, especially used for the analysis of coal to determine amount of the moisture, nothing but percentage of moisture. After that, we see one of the better known classical methods of the quantitative analysis is nothing but a volumetric analysis. So this is mainly based on the difference in volumes of a substances. So that's why this is called as a titration method, titrometric analysis. And in this titration method, a reactant is added to the analyte till an equivalence point is obtained. Okay, so that means the reactants which are reacted with each other in the case of the volumetric, that means volumes in physical state, and they reacted with each other because of the miscibility in between these two substances. That means one substance is soluble in the other substances, then only the reaction is possible, and the titration will continue up to get a equivalence point of a reaction. Okay, so what is equivalence point? Equivalence point means the point at which the reaction is completed. The point at which the reaction is completed. So that is called equivalence point. So based on equivalence point of a reaction, we can choose the required indicators. For example, if you can consider as a different types of the volumetric reactions, there are totally 4 types of the volumetric reactions. The first one is the acid-base titrations, are called as a neutralization reactions. And second one is called as a redox reactions, and third one is also called as a complexometric reactions, and fourth one is called as a precipitation reactions. So all these 4 types of the reactions are comes under category of the volumetric reactions. Volumetric reactions or volumetric analysis. So this method is also called as a titometric method. So for example, if you consider as a neutralization reaction. So neutralization reactions means the reactions are carried out in between the acid and base. So for example, if you consider a strong acid and a strong base, hydrochloric acid plus NaOH, hydrochloric acid plus NaOH. So this is the titration takes place in between the strong acid and the strong base to give a compound nothing but NaCl plus water. So the products are the sodium chloride and water. Both are related to a neutral compound. So that means based on the type of the product, these reactions are called as a neutralization reactions. And the indicator, that means the required indicator, nothing but methyl orange, phenolphthalein, methyl red are based on the equivalence point of a reaction. So based on the equivalence point of a product, we can choose the required indicator. So that is the importance of the equivalence point. And next reaction comes under category of the redox reaction. So redox reaction means the reaction simultaneously takes place both oxidation and reduction. The reaction simultaneously takes place both oxidation and reduction. So that is called redox reaction. So the example for the redox reactions are the titration between the potassium dichromate with Mohr salt. Potassium dichromate. The formula for the potassium dichromate is the K2Cr2O7 versus Mohr salt. Mohr salt. So potassium dichromate means the oxidation state of the chromium in potassium dichromate is the chromium 6, and the oxidation state of the iron in Mohr salt is the Fe2, ferrous salts. So both are reacts with each other to give chromium 3 and iron 3. So that means we observe the from chromium 6 to chromium 3, what happens? The reduction takes place. And iron 2 to iron 3, what happens? Oxidation takes place. So according to definition of the redox reaction, the reaction simultaneously takes place both oxidation and reduction. That is called redox reaction. And the required indicator is based on the potential. So that means there are two couples. One is chromium 6 to chromium 3 couple, and second one is the iron 2 to iron 3 couple. The couple potential of the iron 2 and iron 3 is 0.77 ohms. So based on that couple potential, we choose the required indicator. So that is called DPA, diphenyl amine. Okay, and after that we see complexometric reactions. So from the title we understood that what is the complexometric reaction. So complexometric reactions means the reactions which involves the formation of a compound. So the best application of a complexometric reactions is to determine the total hardness of a water. Total hardness of a water. So total hardness of a water means which involves the determination of both temporary and permanent hardness of a water. So first of all, basically the hardness is nothing but it is mainly caused by the salts of both calcium and magnesium. So calcium and magnesium means the charge which is present in the calcium or magnesium, that is +2. Calcium and magnesium both are containing a +2. +2 means they belongs to the second group of a periodic table. That means the second group of the periodic table elements are called as a alkali earth metals. So the principle involves mainly metal indicator, metal ion, plus reacts with the EBT to give metal indicator complex. Metal indicator complex. So this metal indicator complex reacts with EDTA to give metal EDTA complex. Metal EDTA complex and leave the free indicator. Okay, so the metal indicator complex is less stable compared to a metal EDTA complex. So that means this metal EDTA is final product. So from this product we can determine the amount of the hardness present in a given sample water. Includes both temporary and permanent hardness. Okay, and the required indicators for these complexometric reactions are EBT, erythrom black tea. Okay, and after that we see precipitation reactions. So the fourth one is the precipitation reactions. So precipitation reactions means there is a formation of a compound like precipitate. So precipitate means when the solubility product is less than the ionic product of the water. That means supersaturation takes place. Supersaturation takes place. So condition for the precipitate is whenever the solubility product is less than the ionic product of the water. So, for example, if you can consider the titration between the silver nitrate and potassium chromate indicator to give the compound is nothing but a silver chloride. So, we see the reaction nothing but silver nitrate, the reagent added to the compound like sodium chloride. So, to get a precipitate like silver chloride precipitate and to give a compound sodium nitrate. So, this is called white Caridi precipitate. White Caridi precipitate. White Caridi precipitate. Okay. So, this is the example for a precipitation titration, and potassium chromate is used as a indicator. So all these types of the four titrations comes under category of the volumetric reactions. So this volumetric reactions is purely depends upon the difference in the volumes and to determine the equivalence point of a reaction. Next, we see what are the methods used in the analytical chemistry. So there are mainly two types of the methods. One is the classical methods of analysis, and second one is the instrumental methods of the analysis. Classical methods of analysis and second one is the instrumental methods of analysis. So classical methods is nothing but a traditional methods of analysis. Instrumental methods means advanced methods of the analysis. There are totally two types. One is classical methods and second one is the instrumental methods of analysis. So first of all, the methods used to determine, identify the quantity of analytes in the field of analytical chemistry can be broadly divided into classical and instrumental methods of analysis. That means this classical and instrumental methods of analysis mainly depends upon to determine quantity of a substance present in a given sample. And now we see the first method is nothing but a classical methods of analysis. So classical methods of analysis means there exist many classical methods of checking the presence of or absence of a particular compound in a given analyte. Analyte means sample compound, and one such example is the acid test for gold. So that means especially this quantitative analysis is applicable to in the case of the gold industry. So it is used for to determine the presence or absence of a gold by using a test, nothing but with the help of the acid. So acid means it is also one type of the inorganic compound. Okay, after that we see the second example for the classical methods of analysis is the another example is nothing but classical methods for the quantitative or qualitative analysis is the Castlemeyer test. Castlemeyer test, which employs the phenolphthalein as indicator to check for the presence of a hemoglobin in the given analyte. So that means it is also mainly as best example for a qualitative test, and this qualitative test is mainly involves to determine that presence of hemoglobin levels in the human beings. And third test is the test can be used to check out the presence of a specific elements in an analyte by exposing to flame and observing the required change in color of the flame. So this technique comes under category of the flame emission spectroscopy, FES. Flame emission spectroscopy. So by using our mixture of the components, and it is passed through the sample inlet in this flame emission spectroscopy, and to give the characteristic color of a compound, we can identify what are the compounds present in a solution. So that means, for example, if brick red color is evolved, so calcium is present in a given compound. So that means each and every inorganic metal ion having their characteristic color. Okay, after that we see instrumental methods of analysis. So classical methods means traditional methods, whereas instrumental methods means advanced methods. So now we see instrumental methods of analysis. So first of all we see spectroscopy. So spectroscopy is one of the important and advanced method, and it involves the measurement of the interaction between the electromagnetic radiation and the atoms or molecules belonging to a sample compound. So first of all, what is electromagnetic radiation? That means the radiation which is having both electrical and magnetic properties. One is perpendicular to another one. The radiation is having both electrical and magnetic properties. One is perpendicular to another one. So that is called electromagnetic radiation. The best example for electromagnetic radiations are like X-rays, cosmic rays, and ultraviolet radiations, visible radiations. All of these comes under category of the electromagnetic radiation. So these radiations are irradiated with the given molecule or substance present in a required compound. So that is the spectroscopic technique. After that, we see with the help of electric fields and magnetic fields, the method of mass spectroscopy is used to measure the ratio of mass of the molecule to its charge. So that means this is the technique mass spectroscopy, which is mainly depends upon the molecular mass weights and to identify what are the sample compounds present in a given analyte solution. After that, we see the third method is a common instrumental method used in the field of analytical chemistry is electrochemical analysis. So in this method, the analyte is placed in an electrochemical cell and the voltage or the current flowing through its method. So that means the best example for this method is nothing but a voltammeter. So it is mainly depends upon the flowing of a voltage and current through the method. After that, the interaction between the analyte and energy in the form of the heat is studied in the discipline of the analytical chemistry is known as the calorimetry. So calorimetry means which is mainly based on the visible range. Visible range means it involves the in between 400 to 700 nanometers. So that means the colors which are involved in the visible range. That means all these colors are visible to naked eye. That is called VNSR. So that means violet, indigo, blue, green, yellow, orange, red. And red is placed at the last color because it is having a high wavelength radiation. So because of the high wavelength, this red color is suitable for to identify dangerous situations. So because it is observed from the farthest distance. Okay, so the calorimeter is one type of the calorimetry spectroscopy, which is mainly depends upon that radiation irradiated with the given sample compound with its atoms or molecules. So that means a calorimeter is an instrument that is used to measure that heat of a chemical reaction. Okay, so that is the importance of the calorimetry. So after that, we see the final instrumental method. That it can be noted that even biological measurements are made with the help of this branch of chemistry, and that field is known as the bioanalytical chemistry. So up to the previous one, we see the analysis mainly involved in the clinical analysis and also titometric analysis and also gravimetric analysis. If this analysis is further extended to the biological field, that is called bioanalytical chemistry. Okay, so there are mainly two types of the methods of analysis. One is classical methods and the second one is the instrumental methods of analysis. This instrumental methods of analysis is nothing but advanced methods compared to classical methods. And the main advantages of the instrumental methods compared to classical methods are the instrumental methods are done at very low concentrations and there is no need of the indicator in case of the instrumental methods of analysis, whereas in classical methods of analysis they are done with the higher concentrations and they need the indicators. After that, we see what are the branches of analytical chemistry. There are several branches present in analytical chemistry. Let us see one by one. The first one is the two sub branches comes under category of the analytical chemistry, namely quantitative analysis and qualitative analysis. So at the initial stage, already I said that the analytical chemistry mainly depends upon the analysis like both qualitative and quantitative analysis. So which can be explained as follows. So the first one is the two methods from the backbone of a many educational labs of the analytical chemistry. So that means this analysis, that means the analytical chemistry analysis, either qualitative analysis and quantitative analysis, mainly applicable to the either the practicals which is present in the educational institutions like colleges and schools. So the first one is the quantitative analysis. So quantitative analysis is a method of determining the absolute or relative quantity regarding the concentration of a one or more substances present in a sample or compound. That means quantitative analysis mainly involves to determine how much quantity present in a given sample compound. So, for example, take a sample of the unknown solid substance that chemists first use qualitative methods. Qualitative methods means to determine what are the components present in a given sample and to identify what type of compound is present in a given sample. So then he adopts the quantitative analysis procedure to determine the exact amount of or quantity of the compound present in the sample. So some quantitative analysis techniques include gravimetric analysis and volumetric analysis. Already I said that what is the gravimetric and what is volumetric. Gravimetric analysis is mainly depends upon the difference in moles of the substances, whereas volumetric analysis involves the difference in volumes of the substances. So that is the difference between gravimetric and volumetric analysis. After that, we see the second method is nothing but qualitative analysis. The second branch of the analytical chemistry is qualitative analysis. So, quality means the standard or the future of the one of the substances. Hence, the qualitative analysis methods deals with the determination of quality of a particular compound. That means irrespective of its quantity or concentration. That means this test mainly involves to determine the quality of a compound present in a given sample, but it cannot involve any quantitative test. So in simple words, the qualitative analysis does not measure the amount of substance but measures the quality of that material. That means it is especially for quality, not for quantity. And one of the best examples of this type of the methods is observation of a chemical reaction, whether there will be change in color or not. That means especially this is applicable for the spot test. So used in the salt analysis. So in qualitative analysis method can be measured in different ways such as chemical tests, flame test, etc. And several such tests are used in the salt analysis. So that is nothing but a systematic procedure for qualitative analysis. And the salt analysis mainly involves the identification of cation and anion of inorganic salts. So for example, if you consider here the salt like NaCl, sodium chloride, this sodium chloride will be dissociates into two ions, both cation and anion. So this salt analysis involves the test for first anions, first test anions, after that move to test for cations. Okay, so these two tests are mainly involved in the case of the salt analysis. So first of all, we did the physical test like color, odor, and after that solubility. Then we move to the test for identification test for anions. After that, we see the confirmation test for the anions. Next, we move to group separation table. From the group separation table, we can identify which cation is present in several types of the groups. That may be first group, second group, or third group, and fourth group, fifth group, and sixth group with respect to the group ranking. Then we do the individual test for cations in a group separation table. Okay, and in some cases we observe the spot test also. The spot test also identify or observed by the with respect to change in color. Next, we see what is the importance of analytical chemistry. So that means analytical chemistry is the branch which is taught in almost all schools and colleges. That means already I said that in schools and colleges, the practical information is purely based on the analytical chemistry. That may be either qualitative test or quantitative analysis, or it may be depends upon the either classical methods of analysis or instrumental methods of analysis. But the applications of it are made in the pharmaceutical industries. So especially this analytical chemistry techniques is mainly applicable in the case of the pharmaceutical analysis, like advanced techniques of chromatography, like gas chromatography, and HPLC. HPLC means high performance liquid chromatography, and also GCMS and LCMS. That means gas chromatography, mass spectroscopy, and liquid chromatography, mass spectroscopy. These four techniques most probably used in the pharmaceutical analysis, and these four techniques are comes under category of the analytical chemistry. After that, we see food factors. So food factors also mainly involves the to determine the what are the contents. That means both nutrients and also minerals present in a given food type of the compound, and also the life of the that food items, and also chemical industries. In case of the chemical industries, also like analysis of the ores in metallurgical analysis, and also analysis of the complex compounds, which is mainly involved in the industries. Next on agricultural industries. So agricultural industries means analysis of the like pH, zinc, and soil test. All are comes under category of the agricultural industries. And also scientific laboratories. Scientific laboratory means to determine the glucose levels in a blood sample, and to determine the toxic compounds present in a urine sample. And the tools used for this purpose are quite expensive, which one cannot afford at home. That means these techniques are applicable only in industry purpose, but not in domestic purpose. So after that, we see the applications of analytical chemistry. Applications of analytical chemistry. So some important applications of this branch of the chemistry are mainly includes. The first one is the shelf lives of many medicines are determined with the help of analytical chemistry. That means especially in the case of the manufacturing of the so many medicines which are involved in the pharmaceutical industries. Next one, it is used to check the for the presence of alterants in the drugs. Adulterants means it is used to check for the presence of adulterants in the drugs. Adulterants means components or pollutants present in the drugs. And also soil can be tested to check for the appropriate concentrations of the minerals and nutrients that are necessary for the plant growth. So for example, if the plant growth it requires the so much of the pH value. So pH means in between 8.3 to 10, that pH is suitable for the pH growth. After that, it requires the zinc and silica which are present in the soil. So that means especially the soil tests which are mainly based on the analytical chemistry. After that, we see it is also employed in the process of chromatography, where the blood samples of a person are classified. That means chromatography. So chromatography means graphical representation of a colored compounds. Graphical representation of a colored compounds. That is called chromatography. Okay, so this chromatography is especially applicable to determine the blood sample in human beings, and the concentration of pesticide residues and the contaminants in a given food sample can also be determined via analytical chemistry. That means in some cases the preserved compounds, especially preserved food items, they may be converted into the after the expiry date into toxic compounds, and it will be converted into like pesticide residue. In those circumstances, to determine what are the pesticide residues in the food sample compounds, especially by using the analytical chemistry. After that, it has many important applications in medicinal field with its use in the testing of a cholesterol and glucose levels present in the blood sample. So not only even used in the food industry and also human beings and also pharmaceutical industries, even it is also applicable to determine the in the case of the blood sample. That means diagnostic tests. So after that, we see the analytical chemistry is an integral part of forensic science and clinical analysis, and even in environmental analysis. That means forensic science means especially used for the to determine the in case of the accidental and dead bodies analysis, and also clinical analysis. So clinical analysis means it is also involved the to determine the blood levels in the blood levels present in the human beings, especially in the case of the glucose levels present in the diabetic patients, and also in environmental analysis. Environmental analysis means especially in cities, they causes so much of the pollution coming out from transportation of vehicles, like toxic gases like sulfur dioxide and carbon monoxide, carbon dioxide. All these analysis which are involved in the environmental analysis based on analytical chemistry. Okay. So this is about the applications of analytical chemistry. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.